Hello students, hope you are doing well. So here we are again to learn one more important topic from the basic electrical engineering, that is relation between phase quantities and line quantities for star connection. Okay, so first we will do for star connection and after that we will go for delta connection. Okay, so before starting this derivation, we should understand that the derivation which we are going to do it is for symmetrical system and balance system. Okay, so what is a symmetrical system and what is balance system? We need to understand these two terms first. A symmetrical system is said to be symmetrical when various voltages are equal in magnitude and are displaced from each other by equal angle. Okay, see this derivation is for three phase. So in this case we are going to have three voltages, and you know phases are red, yellow, blue, which we consider R, Y, B. Okay, so the magnitude of all voltages are same, supposed to be same, but all voltages will get displaced by equal angle, that is going to be 120. How 120, that I will explain you again. Now what is for balance system? Balance system is said when system is said to be balanced when it has voltages of equal magnitude as well as current also. Current will also have equal magnitude in each phase, and but both quantities will get displaced by equal angle, that is again 120. Okay, so hope you have understood. Symmetrical means equal voltage and displaced by equal angle. Balance system means current as well as voltage, both quantities will be same in each phase magnitude wise and will get displaced by equal angle, that is going to be 120. Okay, now this is a one example for star connection. Here we are having a load which is connected in star. So we have three phases. Okay, and all are connected in star. When we take one end of each phase and connect together, that point is known as neutral, denoted by N. This type of connection is known as star connection. Now if we name these phases by R, B and Y, and this is the sequence which we are supposed to follow, that is red, yellow, blue, or R, Y, B, or in few books you can find this is used as A, B, C. So you can go either one, both are right. The yellow, blue will be your sequence which we should follow. Okay. Now we have to understand what is phase and what is line in circuit. So the part of the circuit which connect the part of the load or the supply which connect to the external circuit, that is known as line. So in the circuit, if you will see, the part which is connected to this, which is going to connect this load to the external circuit, is going to be this part. So this part is nothing but it will be a line. Now what is phase? Phase is the part which is connected between a line and the neutral point. So this is your phase. Okay, so hope you have understood what is line and phase. Now we are going to get relation of voltage and current between line and phase. Okay, now I will tell you how they are getting 120 degree displacement. Supposedly see here we have considered again red, yellow, blue sequence. Okay, supposedly we are considering see these are the vector quantities, so we will consider accordingly. Supposedly VR, that is voltage of red phase, is V. We are taking reference red as, so it will have 0 angle. Now we will go for yellow, that is VY, so it will have same voltage magnitude but displacement of minus 120. Similarly, if we see YB, VB will be same magnitude but angle will be minus 240 or it can written as plus 120. So if you will see, there is phase in each phase, each voltage is displaced by 120 only. And how it is? Because it is, we have overall angle is 360 and we have 3 phase. So we have 3 voltages or 3 currents. So if we divide this 360 by 3, it will be 120. So that is how we are getting 120 angle displacement. Now we will go for derivation. So for that first we have to see the different voltages. Here I am considering supply, you can consider load also, no problem. So this is your R, Y and B. Now this is your neutral point. Now we will see, we will try to mark values. Voltage between R phase and neutral, that will be denoted as VRN, or you can consider it as VR also, no problem. Similarly, voltage between neutral and Y voltage, it will be VYN. Then again voltage between blue phase and neutral, it will be VBN. Now we will go for these voltages are nothing but these are going to be phase voltage. You can see here 3 phase voltages are VRN, VYN and VBN. Now we will go for line voltages. Line voltages will be the voltages which we are going to have between 2 lines. So let's take another color so that you can easily identify. Consider this one. This is your VYB. Okay. Now here again you can consider voltage VBR, and let's take it where to take. So here you can take, this is your, one second, you can take VRY. So these are your line voltages. You can see here I have written that 3 line voltages are VRY, VYB and VBR. So now we can easily understand that VRN, VYN, VBN are your phase voltages, and VRY, VYB and VBR are your line voltages. Now as we are doing this derivation for symmetrical and balanced system, then definitely all voltages are going to have same values. Same value means phase voltages will have same values and line voltages will have same values, but phase voltage and line voltage will have different values. This is very important to understand. Okay, I have written here. So these are your phase voltages and these are your line voltages, and we have represented phase voltage by VPH and VL by line voltage by VL. Now we will move for derivation. If you know the vector quantities calculation, so we can see VRY, if it is a vector, so can be considered as VRN minus VYN if these are vector quantities. Similarly, VYVB will be your VYN minus VBN. Then last one, that is your VBR. So VBN will be subtracted by VRN will get subtract by from VBN. Most important thing is that you should give consideration to the sequence. If we are considering VBR, so VB will get VR will get subtract by VB. Okay, so don't change sequence, it will change the whole thing. Now we have three equations. By considering all one by one, we will draw phasor diagram. Okay, first we will consider phase voltages. We are going to consider as we will draw first phase voltages, and by using phase voltages we will calculate. So this is your very first VRN voltage. We can draw it approximately, okay, by free hand. You can do it in your exam also that ways, no issues. If you will draw it approximately, you will get the exact answer. This is your YN, and finally approximately at 120 it will be VBN. So hopefully you can easily see that in all voltages are getting apart by 120. Okay, these are 120. Now I will consider first equation, that is VRY. VRY is VRY. If you remember, VRY was VRN minus VYN. So we have VRN. Now we have to see where is minus VYN. Minus VYN we will get by extending VYN. So we will extend this approximately. We have extended it, mention it, minus VYN. Now we will use parallelogram method to find the resultant of these two vectors. What is parallelogram method? We will draw parallel lines with both components, both vectors, and wherever these parallel lines will intersect, that will be your end point of the resultant. Okay, let's make it. So this resultant is going to be your VRY. This is the main thing. Okay, and if you see that this angle is going to be 120, and as we extend this vector, so it will bisect this angle, and so this angle is going to be equal to 60. Okay, now if you remember formula for parallelogram method, to get the resultant value, if R is your resultant and its vectors are component vectors are A or B, so it will be R equal to is going to be A square plus V square plus 2AB plus cos theta, where theta is angle between A and B. So we have the same thing. Okay, VRY is your resultant, and here we are going to consider only the magnitude, remember this. Okay, and our components are VRN square plus VYN square plus 2VRN into VYN into cos 60. Now we will put values. So VRY can be written as line voltage, so that is VL and remaining voltages are your phase voltage. So we will replace all phase voltages by VPH. Here we are considering only magnitude, that keep in your mind, and angle between those components are 60. So cos 60. Cos 60 is nothing but it will be 1 by 2. So VPH square plus VPH square plus 2 VPH square into 1 by 2. This 2 will get cancelled out and we will have under root 3 VPH, and this is your final relation of voltage quantities between line voltage and phase voltage. Now we will, yes, this is the summary of calculation, you can have a look. Okay, now we will move for the relation between line current and phase current. So by observation only, if you see this diagram, I have told you before that this is your line part and this is your phase part. So if let's consider that here we are having current IL, and this part of the circuit will have phase current, that could be IR, or here you can have IB and I'm sorry, it should be IY and IB. So these are going to be your phase currents and these are your line currents. So by observing this only, you can easily understand that line currents like IL is going to be equal to IR, this IL is going to be equal to IY, and this IL going to be equal to IB. So we can easily see by observation only that in the star connection your line current is going to be equal to the phase current. This is very simple, you know. So we can conclude it finally. So voltage relation for star is VL is going to be equal to the under root of VPH, under root 3 into VPH, and IL is going to be equal to IPH. So this is your final result, expected final result. Okay, thank you.